First of all, what is Kubernetes? Friends, Kubernetes is an open source system for managing containerized applications across a cluster of nodes. Many times, Kubernetes also referred as Kube or KATS. Basically, Kubernetes provides container grouping, load balancing, and auto healing plus scaling features. This project was started by Google, and Red Hat is the second major contributor along with Microsoft, HP, VMware, SaltStack, and others. Basically, Kubernetes is designed around a single master server and set of nodes that you host the application on. Each node will host one or more containers that makes up the application. Couple of things before starting with Kubernetes. You need to have basic understanding of Docker. In past, I have recorded a video on Docker basics. You can search that on my YouTube channel. If you get Docker basic understanding, then it will be easy for you to understand Kubernetes. Next thing comes, why to use Kubernetes? The reasons are Kubernetes is lightweight and easy to understand solution. The second thing, Kubernetes is modern tooling. Basically, it got CLI as well as REST API support. So it makes it perfect tool for automated applications or the applications which need REST API support. Portability is another great feature because Kubernetes provide public, private, and hybrid cloud deployments, such as you can deploy Kubernetes on Amazon Cloud, Google Cloud Engine, locally on Vagrant, VMware, or on physical servers. Next thing, Kubernetes is highly scalable solution. Basically, if I say a word, you can easily scale it up or scale it down. So that's something about Kubernetes. Next feature, Kubernetes is self-healing. It can take care of auto placement of Docker containers, or basically in Kubernetes terms, they are called pods. It can manage auto restart or auto replication of the containers or the pods. This is something I'm going to cover in next slides, but to give you a quick idea, what self-healing mean. Let's say you have created a replication controller where you have defined, okay, minimum number of containers need to be 3 or 4. Let's say one of the physical node or Kubernetes node dies due to some reason, then automatically Kubernetes will trigger the build of other nodes, like to maintain the number of replicas on the other available physical nodes. So that's something self-healing. And auto restart. Auto restart, basically if pod is not responding due to some reason, then Kubernetes can take care to auto restart that pod. Kubernetes is good for rolling updates. That's another great feature. Now you guys may be thinking, why to use Kubernetes? Is in market any other solution? Yep, definitely there are. Apache Mesos, that's one solution. Hadoop Yarn, and the popular one, Docker Swarm. Docker Swarm is basically Docker cluster. So there are other alternatives, but Kubernetes is popular one because Google is maintaining it and it's widely used in Google. So good to have basic understanding of Kubernetes. Next thing, we need to understand Kubernetes architecture. If we understand architecture, it will make very easy to understand this particular solution, or you can say this particular tool. This is the diagram of architecture which I got from Wiki, and I found it very useful. So let me tell you something. Kubernetes works in master client model. Basically, in a cluster, you will have a master server, which is referred as Kubernetes master. That server runs couple of components. You can see on my screen, like this particular server is running API server, controller manager, scheduler, and etcd. There are other servers which are basically Kubernetes nodes. Nodes are servers which basically host the containers or pods, and basically they host application. So in a single cluster, you can have multiple nodes, Kubernetes nodes, or sometimes they are also referred as minions. I will come to that explanation in a couple of seconds in next slides. But to give you understanding, these are the components which are running on master server, and these are the components which are running on nodes. And between nodes, communication happens using Flannel. And there are other options like you can use WaveNet, you can use Open vSwitch. There are multiple things. Flan is the popular one. So I will cover this particular components in detail in the coming slides. So I will revisit this particular architecture after explaining the components. Then it will make more sense for you guys to understand about this architecture. Next thing, let's talk about these services, then this architecture will make more sense to you. First of all, we need to understand Kubernetes building blocks. So Kubernetes does work as cohesive package. There are several components at play each specific role. Kubernetes got a specific collection of terms, and some of which are overloaded in container cloud space. So what is Kubernetes master? That's a main building block. Kubernetes master, as I mentioned, that's a single host which will manage the cluster and run several core Kubernetes services. Master component provide the cluster's control plane. Basically, that's a host which is managing the other nodes. Master components are responsible for making global decisioning about the cluster, basically scheduling. Scheduling mean Kubernetes master takes care to decide on which particular node a pod need to be created, or you can say master is responsible to identify, okay, this particular node is having less load, okay, let's trigger the build on that particular node. Or that node is heavily loaded, okay, let's pick free one. If you're creating replica, master takes care, okay, on which particular set of nodes that pod need to be created. And master is also responsible for detecting and responding to the cluster events. Let's say you restart a port, you start a port, you stop a port. So all these states are maintained within the master. So it takes care of maintaining the states or detecting the state changes. What is a Kubernetes node? Many times, guys, Kubernetes node is also referred as minion. Actually, till version 1.6, I believe it was referred as Kubernetes minion, but now it's referred as Kubernetes node. If you see somewhere I have mentioned minion, basically minion and node, they are interchangeable terms. If you have worked on salt stack, even salt stack calls the client side machines basically minion. So it's similar terminology, but in case of Kubernetes, just try to say Kubernetes node. Basically, a node is a worker machine in Kubernetes. As I mentioned previously, it was also called minion. Each node has a service necessary to run pods and is maintained by the master component. As I mentioned, master is responsible to manage the services, but Kubernetes node, that's basically running the pods, which are basically managed by the master. A service on the node include Docker, Kubelet, and kubeproxy. So these are the services. As I mentioned, for containers, like Docker is a solution. There are other solutions also, but Docker is a popular one. So Kubernetes can work with different container solutions. In this particular demo, we will stick with Docker, which is the default one on Kubernetes. Kubernetes master and nodes can be configured on physical or virtual or like even hybrid setup. Let's say for master you got physical, for nodes you got virtual machine. Even that setup is possible. But I will prefer to maintain a similar setup. If you are on Amazon Cloud, okay, go with Amazon Cloud for master and nodes. If you got Google Cloud, go with Google Cloud. If you got let's say virtual setup like VMware backend, go with that particular setup. So now let's talk about Kubernetes components in detail. Then I will jump to the architecture diagram. Then it will make more sense to you. First of all, API server. It always runs on master node. API server is used as REST API endpoint for managing most aspects of the Kubernetes cluster. We know APIs are used when a developer or some web application want to make a call to your machine using API call. So in that way, this particular service is getting used. Replication controller, again, that runs on master node. It ensures number of specified pod replicas are always running by starting or shutting down pods. What is mean? Let's say you have requested like minimum number of 3 pod replicas in the replication controller, then replication controller service is going to make sure there are always 3 running replicas. Let's say one of the physical node dies where one of the replica was running. Then Kubernetes replication controller service will make sure it triggers the build of third replica on healthy nodes. Scheduler that again runs on master. Scheduler basically finds a suitable host where new ports will be residing. What it mean? Scheduler checks, okay, what is the load on target node? That machine is heavily loaded or not healthy, or let's say we have configured that machine that don't create any new pod on that particular machine. Let's say we have freeze that particular node, and Kubernetes scheduler service know, okay, that node is freezed. Okay, this is not my target to create new pod. It will check the appropriate or the free node basically. Next service is etcd, which always runs on master node. It is a distributed key value store where Kubernetes store information about itself, about nodes, and about pods, as well as the services. You can say this is registry service for Kubernetes. If you guys have worked on VCS, if you remember, like we can create the VCS repository where we keep all the meta about that particular cluster, the information. That's something like etcd. Next thing is pod, which always runs or gets created on nodes. It is a single schedulable unit of a Docker container. It always have unique IP because Docker container. Uh, Generally, that works with the DHCP IP, and IP is always unique. Another thing which I haven't mentioned here, but for a pod is not a migratable unit. Like let's say you have created a pod on node 1, you can't migrate it to node 2. I'm repeating, if you got one pod created on node 1 with name pod A, you can't migrate similar pod to other node, but you can destroy that on 1. If you're not using it, you can create it on second node. That's something. Next service is Kubernetes that always runs on node. That's host level pod management. It determines the state of pod container based on the pod manifest received from the Kubernetes master. Basically, what happens whenever you are kicking off pod build, you are kicking off that from Kubernetes master. Kubernetes master then sends the manifest to the node, and node determine the state. Okay, like this particular pod need to be started or created. So that basically Kubernetes service that maintains that particular thing, and Kubernetes service communicate with the master using the proxies and Kubernetes component. Next thing is proxy. Again, that service runs on the nodes. It manages the container network, IP address and ports basically based on the network service manifest received from the Kubernetes master. Again, this service is dependent upon the Kubernetes masters. Next component is Docker, which always runs on node because there is no requirement to run Docker on the master because we are not going to create Docker or pods on master because master is only to manage the nodes and other components. So Docker always runs on nodes. We all know what is Docker. That's container management solution. Instead of Docker, you can use other available container solutions, but as I mentioned earlier, we will stick with Docker because that's a default one. Next component is cAdvisor. cAdvisor always runs on nodes. It provides container user an understanding of the resource usage and performance characteristics of the running containers. So that's something for your resource utilization and performance characteristic data. Next and very important service, which is Flannel. Flannel provides network overlay that allows container to communicate across multiple hosts. What it mean? You got two, let's say for example, you got two different nodes. How those two nodes are going to communicate with each other means the Docker containers which are created on those two nodes, how they will communicate with each other. Flannel is the component which is going to make a network overlay which will allow the communication between Dockers or Docker containers across different hosts. So this is something about theoretical component. Now you got idea about what are the components. Let me jump to the architecture diagram, then I will explain the bits quickly. So I'm repeating, developer or operator, that particular operator hits API server. API server then checks with the controller manager, or that's replication controller and scheduler, and etcd is the database where all the information or configuration is saved, as I mentioned. Okay, after that, when user want to do the activity, basically, then it communicates with proxies, and you can look here, like API server basically communicates with kubelets, here kubelets, and these are the ports. Ports are virtual entities. You can see this particular bridge, which is Flannel, that's network between Kubernetes nodes. And cAdvisor, as I mentioned, that's for getting performance or resource utilization stats. In this example or this architecture diagram, we got two nodes. This is cluster, complete cluster. This is master, green one. This is first node. This is second node. So that's something Kubernetes architecture. And I don't remember exact figure, but in version 1.6 of Kubernetes, you can have multiple nodes. I believe it supports 1,000 nodes, and every node can host around 100 ports. Ports are basically containers, as I mentioned. So you can think of like how scalable this architecture is. For reference, like I use this particular Kubernetes page and this Wikipedia article. You can go to website of Kubernetes if you want more understanding. The reason why I'm recording this video because I was struggling to get information because information is available in bit 10 pieces, and when you are not expert on that particular Kubernetes thing, then you will always struggle. Okay, from where I have to start? So I just thought to record a video to give you idea from where you can start on Kubernetes. In the next video, I'm going to demonstrate how you can create your first Kubernetes cluster. Then my idea is once cluster is ready, we will perform some cluster or Kubernetes cluster management operations, like how to disable a node, how to drain a node, how to re-enable a node, kind of things. After that, another video I'm going to record that is going to be on Google Kubernetes ports. Ports basically how you can create a container inside Kubernetes with the Kubernetes manifests. So that's something idea. Then we will talk about replication controllers. So that's agenda. Stay tuned and watch the next video, which is going to be on Google Kubernetes ports.